So on question 3, we've got some different equations to solve just to show all the different ways complex numbers could come up. We're going to start out with a quadratic, so you should know how to solve this. You've got two options really, given the topic's complex numbers. We're going to use the formula, so negative b plus or minus b squared minus 4 times a times c over 2a, and then you can simplify that. Or you could complete the square if you like completing the square. So it's going to be x plus 2 squared plus 2 equals 0, and then you can rearrange that. Remembering that when we square root, it's going to be plus or minus root 2i. So x should be negative 2 plus or minus root 2i. With this, both of these can be checked in the calculator. Remember that you'd need to show the method if it asks you to solve the method. Remember, we've got equation solving mode, it's a polynomial, it's order 2, and then just stick the coefficients in, and hopefully it will agree with our answer. There you go. Okay, so question B, then, so B, you can see we've got a little bit more work to do here now. So we've got an expression here, and I've got some brackets, and we'll start with multiplying that out. So I have 2z plus 3i times z plus 3 minus I is equal to iz plus 1. Now here we're trying to find z, but we've got a real number times z, and we've got an imaginary number times z, and z is going to have real and imaginary parts itself, so we need to split those up. So I'm going to say z is a plus bi, and then replace it. So I've got 2 times a plus bi plus 3i bi plus 3 minus I equals I times a plus bi plus 1. So I've now got 2a plus 2bi plus 3ai plus 3bi squared plus 3 minus I is equal to ai plus bi squared plus 1. Right, so that's going to give me 2a plus 2bi plus 3ai, because we need to change all the I squareds, because they're a real number, they're negative 1. B plus 1. Now I'm going to split this up into real and imaginary parts. So let's have a look. Real, 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 real. And then I've got imaginary, 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 imaginary. Okay, so the real parts are 2a subtract 3b plus 3 equals negative b plus 1. My imaginary part is I've got 2b plus 3a minus 1, because my side is going to be minus 1, is equal to a. You can then simplify those and solve the simultaneous equations however you like, remembering once again you have got simultaneous equation mode on the calculator. So 2 unknowns, but you do need to arrange this so you've got so many a's, so many b's equal to a number before you use it. Right, so I've rearranged my 2 equations so I can type them in the calculator, and this tells me x, that's what I had as a, is negative a quarter, and b is 3/4. So a is negative a quarter, b is 3/4, so that means z is negative a quarter plus 3/4 times I. Now, there is an alternative way to do part B. The other way to do it is to work with what we've got here. So I've got 2 plus 3iz plus 3 subtract I equals iz plus 1. Now I could move, just like you would when you're solving equations, I'm going to put all the z's on one side and everything else on the other side. So that gives me 2 plus 3i times z. Take away iz equals, it's going to leave 1, subtract 3 plus I. Simplify this side a bit, so that's the same as 2 plus 2i times z. Sorry about the handwriting here. Simplify this bit, negative 2 plus I. And now I can get z by dividing those two complex numbers, which again you could do in your calculator, but remember really if we're going to do the correct method we want to realise that. So I'm going to multiply by the conjugate of the denominator, and then if we work all this out you should find we get to the same answer. So some brackets in there. Right, so that gives us negative 4 plus 4i plus 2i, take away 2i squared, all divided by 4 minus 4i squared, which is going to give us negative 2 plus 6i divided by 8, which you should be able to see is the same as what we got using the other. And C, we're trying to find x and y, so the most sensible thing to be probably is going to be to expand these brackets. Okay, now we've got an I squared there, so we need to simplify that. Always simplify I squared whenever it comes up. Then we're just going to split into the real, so that's my real parts, and my imaginary parts. Okay. So just make that sensible thickness. Okay, so the real parts I've got 2x minus y equals 3. My imaginary parts, I've got x plus 2y equals negative 1. That's very nicely in a format that you can solve or just put into your calc. And that will give us x equals 1, y equals negative 1. Right, D, you've got a couple of options. You can realise both those fractions separately and then put them back in subtraction. Depends what you prefer here, or we can multiply everything by 1 over x plus y to start with, so that'll give us 1 minus x plus iy over 1 plus I equals 2 minus 3i times x plus iy, and then we can multiply through by 1 plus I there we go. And then we could solve that, so we're going to end up equating with the imaginary parts. So here I've got 1 plus I, subtract x, subtract I and y. Here
We've got a bit of multiplying out to do. Let's just do that one part at a time. And then multiply through by the 2 and the 3i. That's a plus. It's going to be plus 3x because we'll end up with negative 3i squared. It's going to be a plus 3y for a similar reason. And on this side I've still got 1, 2, 3. I might as well put the real and imaginary parts together.
then, just as before, we separate into real. I'm going through looking for anything that's got an I in it. And imaginary, which will give us two simultaneous equations to solve. Let's very quickly do that. So real 1 minus x equals 2x minus 2y plus 3x plus 3y. Imaginary 1 minus y, because an I on its own is 1i. 2x plus 2y equal 3x y, and then you can solve that. Once you've got your final answer, don't forget you can check it by substituting it back into the original expression here. If you put it into the left hand side, put everything in your calculator, you'll see it does indeed equal 2 minus 3r. Right, in part E, you can see we're solving z and its conjugate. A good way to solve this is to replace z with a plus bi or x plus iy, pick your favourite letters, and that means, oops, we can then replace its conjugate as well with, let's just get back into here, so then we can replace the conjugate with a minus bi, and if you look back at the previous questions, then what we want to do is expand this out, equate the real and imaginary parts, solve for a and b. F is one which gives us the technique for finding square roots of complex numbers. So here we're going to replace z with a plus bi, and it's just the same as many of our other equations. Expand these brackets just like we've done before. Okay, a little bit more complicated to solve now, so we need to rearrange to get one of the letters in terms of the other and then substitute in. Right, your calculator can solve quartics if you'd like to solve it by hand. One way is to pick another letter, and then you can rewrite this as a quadratic equation, which you can then solve using the usual methods, and then you just need to remember that y was b squared, and then substitute that back in and square root your answers to find what b was. Okay, now these are the answers I've got from my calculator. We need to remember that b is going to be a real number, so we reject that one. B is plus or minus 1. Now that makes a, if we substitute back in, plus or minus 4. So therefore we can get that. Here was our original equation, z squared equals 15 plus 8i. So z equals, now we've got to pair these up. So when a was 4, b was plus 1, and then we've got a second solution when a is minus 4, b is negative 1. And you can check that by finding z squared for both of those.